Okay guys, we'll be starting with demo session. Okay, hope you guys are able to view my screen. At any point, if you have any questions, probably you can ping it over the chat. I'll give some time for you guys to answer your queries, right? And this demo session will proceed this way. First of all, I'll talk about Hadoop. Yeah, uh, I'll talk about Hadoop, and then I'll talk about big data. I'll talk about some cluster and all the stuff. Then I'll be talking about the course contents of this particular course. I mean, what I would be covering and what sort of case studies I'll be dealing with, and all the details is something that I'm gonna explain. I'm gonna explain in this demo. First of all, let me introduce myself. Myself, Surya. I've been working for data analytics on Bank of America credit cards. Yeah. Basically, I work for Hadoop and few of big data tools like Vertica, right? And we do some lot of visual analytics on fraudulent transactions of through Bank of America credit cards. I mean, we'll use something called a very popular tool called Tableau, right? Which is a visual analytical tool. Okay, coming to big data. What is big data here? Because probably when you hear about Hadoop, the most common word that you'll hear about is big data. What is big data here? Big data is basically collection of larger data sets in the range of petabytes, zettabytes, exabytes, but not in the normal range of tens of gigabytes or megabytes. Big data is basically something which is in the range of petabytes, gigabytes, thousands of gigabytes, right, terabytes and stuff, which is difficult to be stored or analyzed in RDBMS. So I'm reiterating, big data is collection of larger data sets in the range of petabytes, exabytes, zettabytes or thousands of gigabytes, which is difficult to be stored or analyzed in normal RDBMS. So we understood what the definition of big data is, but there are two constraints here. Why big data is not been able to store in RDBMS or analyze in RDBMS? Simple reason. Let's look at one after the other. Simple reason why big data is not able to store in RDBMS is because if you look at the current trend of data production, let's talk about British Telecom. British Telecom per day produces 12 terabytes of data. Bank of America produces 9 terabytes of data per day. Facebook per day produces 15 to 20 terabytes of data, right? And the amount of data stored in YouTube per day is almost like 25 terabytes of data. Right. So if this amount of data is being produced on daily basis, and if you look at New York Stock Exchange, which is again producing 9 terabytes of data, United Healthcare is producing 8 terabytes of data. I mean, almost all sectors of organizations are producing very huge data. But where do they store the data? If they store the data in RDBMS in a traditional manner, down the lane, probably after 1 year of storing this huge data, they will not be left with any physical space left to attach few more hard disks. Because when they are storing the data, they got to attach hard disks to their server, right? So down the lane, if Facebook is using RDBMS to store the data, there will be no physical space left in Facebook data center, right, to add few more hard disks. As simple as that, because the compression techniques in RDBMS are very poor. So the data, how much of data you wanted to store, it will be stored as it is. So there will be a lot of problem in the future to store this sort of huge data. That's one constraint. And another constraint is, like I said, big data is something which is difficult to be analyzed in RDBMS. Why? Simple reason. Why big data is difficult to be analyzed in RDBMS is probably, let's say that I have some 10 billions of records. Two tables, each having 10 billions of records. One is employee table, which has employee number and employee name. Another thing is, let's say, employee table again, which has employee number and employee designation. Okay, so probably in employee table with employee ID and employee name, if I wanted to select something by filtering something else, right, it's gonna take some time because I have 10 billion records in this table. Okay, and that's fine. If it is taking that some time, that's fine. But now I wanted to find out employee name and employee designation, right? So when I had to find out that, probably I'll have to join these two tables based on my employee ID, right? So when I had to join two tables based on employee IDs, which are of each of 10 billion records, my situation would be more pathetic, because in RDBMS you have a lot of constraints. You have primary key, you have foreign key, on top of which when you are joining, your situation will be really pathetic, right? The output will take larger amount of time. Yeah, not only that, you are gonna utilize a lot of your temporary space, which is gonna put all other operations in halt, or probably it might slow down other operations running in your database. So that's the reason why I told big data is something which is difficult to be stored or analyzed in RDBMS. So finally, big data is a term. It's not a technology. It's not a process. It's a term. Use it to represent larger data sets in the range of petabytes, zettabytes, or thousands of gigabytes, which is difficult to be stored or analyzed in traditional RDBMS. Pretty much straightforward, right? So this is whole thing about big data. Now, as I said, big data is something which is difficult to be stored or analyzed in RDBMS, but where do we store it? Big data comprises of many formats of data: structured, unstructured, semi-structured, right? Many things of data will be there. So where do you store it when, if not RDBMS? So that's where there are many big data tools like MongoDB. There is something called Cassandra. There is something called Vertica. There is something called Hadoop. Many things are there in the market. So each has its own advantages and disadvantages as well. But comparatively, I would say, far better than other tools. Hadoop is pretty much efficient in dealing with big data. Why? To understand this, probably we'll have to look at what is Hadoop first of all, right? Then we'll discuss about the factors. Yeah. Again, Hadoop is not a tool. Hadoop is not a technology. Hadoop is a framework, right? Hadoop is a software library which is a framework that is written in Java. I'm reiterating, Hadoop is a software library which is a framework that is written in Java, which allows distributed processing of large data sets across clusters of computers using simple programming models. Yeah. So Hadoop is a framework written in Java, which Hadoop is a framework which is written in Java, which allows distributed processing of larger data sets across clusters of computers using simple programming models. So before understanding the word the definition of Hadoop, let's look at two technical jargons. One is Hadoop comes with a distributed file system called HDFS and a programming model called MapReduce. So we'll have to understand these two. Hadoop distributed file system, which we'll be calling as HDFS from here on, and a programming model called MapReduce, which we'll be calling as MR from here on, right? So what are these two technical jargons? If you learn that, then we'll be coming back to this particular definition and discuss about what Hadoop is. Yeah. So let me go to next slide. Right. I have a general example which gives you a very high level information of what HDFS and what MapReduce is. Right. To explain you that, let's assume that I have a client who had given me some 100 bricks. Okay. I have a client who had given me some 100 bricks to place it from one place to another place. Yeah. So probably I'll have to take this 100 bricks from one place and I'll have to put it in another place. And what I did is, for this client requirement, I have recruited a person. I asked him to put this bricks from one place to another place. Then this guy had told, hey, I'm gonna do this in 100 minutes because I'm gonna take 1 minute to place each brick. So obviously he would take 100 minutes, probably even more than that if he's taking rest in between. So when I told this to my client, hey, I'm gonna take minimum of 100 minutes to place this 100 bricks, what my client told was, no, you got to complete this in 10 minutes. You don't have 100 minutes to complete this task. That's the reply from my client. So I have no other go apart from recruiting 10 more people, sorry, 9 more people. Totally I'll have 10 people in my hand. So I have 10 people in my hand. So what I did was I've asked each person to lift some 10 bricks from one place to another place. So each guy will take 10 minutes to place these bricks. So totally my task will be done in 10 minutes because for each person I have given 10 bricks. So when I have given 10 bricks to each person, finally, when I combine everyone, it would be only 10 minutes to place this 100 bricks from one place to another place. So what I did was I distributed the work among different persons, right? Rather than having this work done by a single person, I have multiple persons to do this work, but I have distributed the work among different persons. That's what I have done here. But what is HDFS here? Because now that I am using multiple resources to complete a task, they should work distributedly. Because when I distribute my task, they should be able to work. That's what HDFS is, Hadoop Distributed File System. Hadoop Distributed File System is a group of file systems which allows you to work in a distributed manner. So it's not a single file system, it's a group of file systems grouped together, like how we grouped this 10 people. So they will work in a distributed manner. So what I'll do is I'll ask one file system to process something, and I have some part of a process. I have a process. So what I'll do is I'll split this process. I'll ask one file system to process some part, another file system to process one part, and another file system to process one part. So that means I'm distributing the work among different file systems. That's what HDFS is. Hadoop Distributed File System is group of file systems which allows you to work in a distributed manner. Right? Now, that's fine. I have made my work distributed. Distributed my work among different file systems. That's pretty much fine. But how did you distribute it? How did you split the task? What mechanism did you follow? Right? So that's important thing. And when I'm talking about multiple resources here, right, at the end, when you are doing your work with multiple resources, your part of your output will be present in one resource. Your part of your resource, part of your output will be present in another resource. Like that, I have my output segregated among different parts. So finally, I cannot ask my client, hey, your part of output is present there, part of your output is present here, please go and collect it. You cannot say that to your client. You had to combine it and give it to the client. So who is going to do that? Two things. One thing is, what mechanism are you following to split the task? Second thing is, how are you combining your output? Two things. So that's where your MapReduce comes into picture. So when I've split 100 bricks among 10 people, I'll have to tell, hey, first person take this 10 bricks, second person take this 10 bricks. So how did I tell? That is simple, using mapper. So when I say MapReduce, MapReduce is a programming model which has two technical paradigms. One is mapper and another thing is reducer. What is mapper gonna do? Mapper is going to split your task among different file systems or resources in this example. So mapper is someone who is gonna split this 100 bricks into 10 bricks for 10 resources. Yeah. So when it comes to HDFS, mapper is a programming model which would split the task among different file systems. As simple as that. And we have reducer who would come at the last and combine the result processed by multiple resources or multiple file systems. Yeah. And it will give it to the client. The combined result will be given to the client. That's what reducer is doing. So when I have mapper, which splits the work, and I have reducer which will combine the final result and give it back to the client. So that's whole thing about MapReduce. So HDFS is Hadoop Distributed File System, which is group of file systems grouped together, which allows you to work in a distributed manner. When I have MapReduce, MapReduce is a programming model which has two technical paradigms. One is mapper and another thing is reducer, wherein mapper allows you to split the work to make it work in a distributed manner, and reducer is something which combines the final result and give it back to the client. So that's whole thing about HDFS and MapReduce on a high level, right? So any questions on this? Anyone? Bhargava, Durga Prasad, Hari Kishore. Any questions? Probably you can ping me. I'll take your questions. I have a couple of minutes to answer your questions on this particular slide. Sweta, I have Kunda Reddy, Ramu, Rajshekar, Raghu, Premnath, anyone? Raghu's question is, do we need to know Java to do Hadoop? Probably I'll get back to that question, Raghu. That's a pretty good question, I should say. I'll come back to that. Do we have any questions on this particular slide? So I don't receive any pings, so I assume that, oh, our ping. Ramu is asking, is MR a part of HDFS? No, Ramu. MR and HDFS are two different things. MR is a MapReduce, which is a programming model. HDFS is a Hadoop distributed file system, which is a file system. So your programming model has to run on top of your file system, right? So these two are not combined. There are two different things, right? MR is purely a programming model where you'll have to write your programming. HDFS is purely a file system like your Linux file system or your Unix or CentOS, something like that. Probably this answered your question, Ramu. Yeah, probably I've unmuted you, Ramu. You can ask your question.
Yeah, actually what I'm asking is, like, you said MR and HDFS are two different parts, right?
Correct, correct.
Yeah, like what I'm saying is, like, you said HDFS is a, you said you need to distribute the file into smaller packets, right?
Exactly, correct.
Yeah, is that MR or HDFS, like distributing the data into small packets? Is
that will be
HDFS
done by MapReduce. Splitting the work will be done by MapReduce, right? And distributing is something that will be automatically done by the Hadoop architecture. Probably down the lane you will understand how this is how this distribution is happening automatically, right? But Mapper is something which splits the work among different file systems in your HDFS, and your file systems are something which will do the actual process, because these are the resources who is doing the actual process. And finally, once the process is done, reducer is something which combines the result.
Okay.
Got it, Ram?
Yeah, thanks.
No problem. So any other questions? Okay. I assume that everyone is good with this. Then I'll go back to the definition of Hadoop. Please feel free to ask your questions. Yeah. Okay, someone else has raised the hand. Who is that? Oh, Ramu again. Ramu, you have any other questions? I see your...
No, not me.
Oh, okay. Okay. Fine. Then I'm proceeding further. So going back to the definition of Hadoop, Hadoop is a software library which is a framework that is written in Java, which allows distributed processing of large data sets across clusters of computers using simple programming models. So now this makes sense for you. It's a framework. What is a framework here? Framework is a group of components which can be attached or dispatched at any point of time, right? So even Hadoop has a lot of ecosystem components which can be attached or dispatched at any point of time. That's why we call it as a framework. So from here on, if someone asks you what is Hadoop, Hadoop is not a technology, rather it's not a tool, It's a framework. That should be your answer, right? But it allows distributed processing of large data sets across clusters of computers called HDFS, Hadoop Distributed File System, using simple programming models called MapReduce. So that's the definition of Hadoop, right? Okay. Just let me explain you what is a cluster is, then it makes more sense about what is Hadoop, right? This is how a cluster looks like. Probably I'll take a system, I'll call it as a node. When I have group of systems or group of nodes, I'll call it as a rack. When I have group of racks, I'll call it as a cluster. Pretty much straightforward. So when I have group of nodes, I'll call it as a rack. Group of racks, calling it as a cluster. So coming from the way of cluster is group of racks, rack is group of nodes. So when you look at this cluster, I have three different racks. Rack 1, rack 2, rack 3. All these are controlled by a network switch. So this is the main switch of this cluster, right? And this is the one which controls this entire racks. He's the master, I should say. And I can tell you, see, these racks are something that can be located in different physical locations. Let's say rack 1 is located in North America, rack 2 is located in South America, rack 3 is something which is located in Asia Pacific. Okay, so when I have these three racks located in three different locations, probably let's say due to some natural calamities, my rack 1 in North America has gone down. Due to some natural calamities, this rack has totally gone down. So with this, I cannot put my cluster on halt. I cannot put all the operations on halt because I still have two more racks. So cluster is something, at least Hadoop cluster is something, though one of your rack goes down, it will be able to run with the other racks available. That's where it is offering more flexibility for your business continuity plan, BCP. Because at any point of time, let's look, if World Trade Center has gone down and if you have one of your rack is located in World Trade Centers, you cannot put your operations on halt, right? Because you have other racks available, your cluster should be up and running. But to accommodate this thing, what Hadoop does is, it's gonna copy the data present in your rack 1 to rack 2 and rack 3. Some part of the data will be there in rack 2, some part of the data will be there in rack 3. Similarly, rack 2's data will be there in rack 1 and rack 3, and rack 3's data will be there in rack 1 and rack 2. So this is what we call it as a replication factor. Probably there is a lot of internal thing involved in it. Down the lane, when we are discussing about Hadoop architecture, we are going to discuss about many things. Replication is something we have, and we have something like rack awareness, many things. Yes, someone has raised the hand. Probably just give me some time, I'll get back to your question. So cluster is group of racks, rack is group of nodes. So when I have racks, probably each rack will be presented will be present in different physical locations, which will make my cluster to be up and running at any point of time, though any of my rack is gone down due to some power failure or any other thing. So this is whole thing about cluster. So going back to Hadoop definition, Hadoop is a software library which is a framework which is written in Java that allows distributed processing of large data sets across clusters of computers called as HDFS and using simple programming models called MapReduce. As simple as that. Now I suppose this Hadoop definitions makes totally sense to you. So from here on, if someone asks you what is Hadoop, Hadoop is a framework, right, which processes large data sets called big data using something called HDFS, and for processing, what do we use? We use something called MapReduce. So MapReduce, like I said, is a programming model, right? So we'll have to write these programming models. As a developer, it's your responsibility to write these programming models. So how do we write it, right? So after all, Hadoop is a framework which is written in Java, right? So people say that, or people believe that you have to write your MapReduce only in Java. That's fine. You can write your MapReduce in Java. but that's not the only thing. If Java is the only thing in Hadoop, Hadoop wouldn't have got this sort of prominence. Hadoop has a lot of things apart from Java, because if you are a Java developer, that's fine. You write your MapReduce in Java. If you are not a Java developer, then it's pretty much fine. You can write your MapReduce in any other programming language like Python, Perl, C, Shell, anything, or functional programming languages like R, Mahout. You can use anything to write your MapReduce programming. But if you tell me that, hey, I'm not at all a programmer, then it's pretty much fine. Like I said, Hadoop is a framework which has a group of components to be attached or dispatched at any point of time. So that means Hadoop has a lot of ecosystem components, like you have something called Hive, you have something like Pig, you have something called Impala, Uzi, Scoop, Flume, many things are there, right? So if you're not a programmer, you can make use of these tools and you can get your work done. Because at the end of the day, what you are going to do with Hadoop is you are going to do data analytics. When you are doing data analytics, yes, you can do it using MapReduce, or you can do it using any, you can, when I said MapReduce, you can do it using Java, or you can use any other high-level programming languages. If not programming languages, you can use ecosystem components of Hadoop. How is something you will understand probably when we are proceeding, right? So I have a question with MM. Probably MM, I'm unmuting you. Probably you can ask your question now. I see you have muted your microphone. I see you have raised a hand, so.
Let me unmute it. Are you able to hear me?
Yes, of course. Please go ahead.
Are you able to hear me?
Yep.
Yeah. Hey, this is Mahan. Yeah.
Okay.
So I have a question. When you talked about the replication, is it SAN level replication or is it transaction level replication? Like, how can we determine that?
It's a data level replication, I should say. Probably, yeah. Probably. I'm hearing my echo, Maham. Can I put you on mute?
Sure.
Thank you. See, when I have a file, let's say when I have a file of probably, let's say 198 MB. Okay, why I'm specifically talking about 198 MB is something that you'll understand later on. But let's say that I have a file of 198 MB, and this file will be split into 3 parts. Like I said, when a file comes into Hadoop, it will be automatically split into parts so that it will be stored in a distributed manner in HDFS. So after the file is split into multiple parts, what happens on top of it is each part will be replicated 3 times by default. If you wanted to increase it, you can increase it, or you can, if you wanted to decrease that replication factor, you can decrease it. So your replication factor is happening on top of your data. So when I talk about file which is of 192 MB, now 3 parts of file is there and each part has 2 more replications. So totally 3 replications of each part is present in your HDFS. Yeah. Did that answer your question, MM?
Yeah, that should be good.
Cool.
And one more thing, I have a question.
Yeah,
so
please.
you mentioned that instead of Java, we can use different tools, right? So
of course.
What if a company recommends one particular thing, right? Every company has a standard, like they need to go with Java or whatever thing, right?
Yes,
so,
yes, of course.
How can we survive in that place?
Yes, I'm gonna explain that. That's again a very good question. Probably I'm done with the explanation of Hadoop, at least for the demo. Now what I'm gonna do is I'm gonna explain about what contents I'm gonna deal with this course, yeah, and what sort of case studies I'm gonna explain in this part of course. That will answer your question, MM. Yeah.
Okay. Yeah, that should be good.
Thank you. Okay. Sorry. Does anyone have any other questions? Just give me another 5 to 10 minutes. I'm gonna explain about Hadoop course contents. How efficient is this compared to conventional distributed database? Kondareddy has asked me. Yes, it's pretty much efficient when you compare it with a traditional distributed database. How? You can ask me. Because for analytics purpose, you are using something called MapReduce, right? MapReduce is pretty much efficient right? In analytics purpose, for your retrieval, for your analytics, for your storing, everything you are gonna use MapReduce in Hadoop. So MapReduce is something which is comparatively far faster than your conventional distributed database, right? And probably when we are gonna look at the futures of Hadoop, okay, what Hadoop is doing internally, then you will get a more scope of how far it is efficient. Yeah, did that answer your question, Konda Reddy? Yeah. Okay. I have Harikishore. Yeah, Harikishore, I have unmuted you. You can post your query.
Yeah, this sorry. And the question is like, it was 198 MB, right?
Correct.
192 MB by 3, like 64 MB. We know that the block size is of 64 MB.
Exactly. Because now
so
that...
if you consider like,
Go ahead.
if you consider this data as this file size is of 3 into 64 MB, means 3 blocks you can fit. And if you consider like 3 racks, like 3 blocks of data, I can place this in 3 racks. So replication is essentially like these 3, the file size is equal to 3 blocks, right? And this 3 into 3, like 9 times will be there, right?
Exactly.
The file size
exactly. 194 into 3 times.
Block will be replicated, each block will be replicated in another 2 racks. Like
exactly.
Block 1 will be in, okay, each vector, okay, fine.
Yeah, but probably you can ask me a question like, hey, you are saying that 192 MB and you are talking about big data and you are replicating it 3 times. So that doesn't make sense here, because you are doing some I mean, out of the normalization factor in RDBMS, right? So how is this gonna be supported in Hadoop? When you are creating duplicates of your data, that means you are replicating the data. How is Hadoop able to handle it? That can be a normal question for anyone. It's simple. Hadoop is using some hardware called commodity hardware on a high level. Probably down the lane I will explain about how different commodity hardware from enterprise hardware, right? Just to give a heads up that Hadoop is using something called commodity hardware, which is the very cheapest hardware available in the market, right? And replicates and maximizes data. Is Hadoop meant for reducing data or multiplying data? Shravan has asked me this question. Hadoop segregates the data as per the thing you said. It replicates the data and maximizes the data. Is Hadoop meant for reducing the data or multiplying the data? Shravan, to answer your question, Hadoop is not meant for maximizing the data or reducing the data. It is a framework which allows you to perform some data analytics. Okay, so when you are doing some data analytics, you are doing it in a distributed manner. Now you are doing it in a distributed manner. To support that, you are having multiple file systems. So when you are using multiple file systems, right, so each file system can go down at any point of time. So that's the main drawback of distribution. So any file system can go down at any point of time. So to avoid that particular drawback, how Hadoop is designed is, it will be replicating the data into multiple file systems, so that even one of your file system has gone down, you still have your other file systems to process your data. So that's where Hadoop has got a lot of prominence. So to answer your question, Hadoop is something which can be used for data analytics. Yeah, it's not for yes, it's just taking the backup of your data. That's it. So that that backups will be used whenever one of your data node or whenever one of your file system has gone down. Yeah, so it's not meant for either maximizing or reducing the data. It's meant for data analytics. Got it, Shravan? Okay, cool. Yeah, I'm going to explain about the course contents which I'm gonna deal with in this particular session. Yeah, just give me a moment. Yeah, so these are the course contents I'm going to deal with in this session. But let me tell you, this session is not something that's going to cover much of the theoretical concepts. Yeah. So probably I'll talk about 10 to 15% of the theoretical concepts. Rest 85% would be purely practical, which gives you some real-time exposure of how the things happen in Hadoop. So to to make this happen, if you are continuing in this batch, probably I need almost like at least one hour or 1.5 hour effort from you on daily basis. So if you are going to put that at the end of this course, probably you should be at least proficient in Hadoop. Minimum thing is you should be proficient in Hadoop. You should be able to crack interviews. So how this programming, how this particular session continues is something that I'm going to explain. Yeah. So in this session, this particular hardware description or Hadoop discussion about Hadoop goes for 3 to 4 sessions. I'll talk about Hadoop architecture. I'll talk about how different Hadoop is from RDBMS. I'll talk about internal things of Hadoop. What happens internally in Hadoop? How daemons communicate with each other. Yeah, and I'm gonna talk about what factors that might bring down your cluster. All the details is till the networking concepts of Hadoop I'm gonna discuss. And soon after that, I'm gonna discuss about Linux. At least for one session, or probably more than one session, I'm gonna discuss about Linux. You can ask me why Linux is required. Because soon after discussion of Hadoop and soon after discussion of Linux, I'm gonna discuss about how to set up Hadoop, how to set up a pseudo-mode cluster, right? So I'm gonna set up a cluster. Yeah, I'm gonna give some documentation for you. For everything there will be a detailed documentation. So I'm going to give this documentation for you. You can do it on your own. You can configure, you can develop your cluster. So that's what I'm going to talk about in this particular discussion of setting up a Hadoop cluster, right? Soon after this, I'll give you the document. You can refer to the video, recorded video of that particular session, and you can set up your own cluster. So to set up a cluster, you are doing it on top of Linux. So when you are doing it in top of Linux, you should be aware of Linux. That's a mandatory thing. If you don't know Linux, doesn't matter. I'm gonna explain Linux and I'm gonna bring you to a comfort zone of Linux, right? And once Hadoop setup is done, I'm gonna talk about HDFS commands. Again, here your Linux commands are gonna be very useful because HDFS commands are almost 80% similar to Linux commands. That's the reason why I'm taking a separate session for Linux. So it will be useful for me to set up a cluster and again doing some HDFS commands, right? So at the end of HDFS commands, I'm gonna talk about some real-time scripts. Custom scripts. How do we write some custom scripts using Linux to automate some tasks using HDFS? I'm gonna give you a case study to write some custom scripts on HDFS. So this is the place where your case studies will start. Okay, and even when I'm discussing about Linux, I'll give you smaller tasks, but from HDFS part, I'm gonna give you case studies. And soon after HDFS, I'm gonna talk about core Java. See, when I'm talking about MapReduce, it's not complete Java that we require. It's something called core Java that we require for writing MapReduce. So I'm going to talk about all the concepts of core Java that is required for you to develop some MapReduce code, right? So soon after discussing about core Java, I'm going to discuss from a level 0 MapReduce code to very high level MapReduce code, which can be like, I'll take you to a level of data analytics on images. How do you do some image analytics through MapReduce is something I'm going to discuss. I'm going to discuss about different phases in MapReduce like mapper, reducer, combiner, partitioning. You have something called sorting, splitting, shuffling. Many things are there. We have internally, we have spilling, right? And we have in-memory buffer, accounting buffer. Many things are there. I'm going to take you to a level of proficiency on MapReduce. So for that, I'm going to start with a very basic code to a level of image analytics using Hadoop, or rather I would say MapReduce, right? These are the things I'm going to discuss when I'm discussing about MapReduce code, That will be discussed soon after Java. So once I discuss about that, again I'm going to give you a case study on MapReduce as well. So this is how your abstract file will look like. I'll give you a data set and I'll give you some abstract files. So looking at this and looking at your data sets, you are going to work on your MapReduce case study, right? So after MapReduce, I'm gonna start with Hadoop ecosystem. Okay, before that I have something else. So like MM had asked me, like, hey, if someone fixes, like, one thing is Java is widely used for writing MapReduce, and another most important programming language used for MapReduce is Python. So soon after Java, I'm gonna discuss about Python fundamentals, and I'm gonna talk about how do we write MapReduce using Python. That's using again streaming. I mean, we call it as MapReduce using streaming. So I'll explain that as well. Okay. So if you are a Java developer, probably you go with this. If you are a Python developer or any high-level programming developer other than Java, you go with this. Probably I have answer for other people who are not at all a programmers as well. I'll explain that now. So with this, your MapReduce section will end. This might probably take some 10 days to complete MapReduce, Java. I mean, when I say MapReduce, first Java fundamentals and then MapReduce in Java and MapReduce in Python. So these are the things that I'll discuss as part of MapReduce code. Right? 1 second, please. Okay. So soon after this MapReduce course, I'm gonna enter into Hadoop ecosystem components. I'm gonna start with Hive, right? When I say Hive, Hive is a very widely used ecosystem component of Hadoop, right? I'm gonna talk about Hive basics to a level of data analysis using Hive, right? I'll talk about all the optimization techniques, all the commands available, and I'm gonna talk about something called user-defined functions both in Java and Python. Right. So when I say UDFs, user-defined functions, you got to very frequently write UDFs. So here, this Java and Python sessions are again useful, not only for MapReduce, even for your UDFs it will be useful, right? And again, after Hive, you got to work on some POCs. Again, I'll give you the data set. I'll give you some abstract which explains what you got to do using Hive, right? These are the things I'm gonna give you soon after every component. After every component, you will have a case study for sure, right? And again, I have something called Pig after Hive. So Pig is something, again, another widely used ecosystem component, which is a data flow language. I'm gonna explain about Pig again in very detailed. So I'll have some I'll explain also UDFs using Java and in Python for Pig, and then soon after that I'm gonna give you again case study on Pig as well, right? So soon after that you will have something like Scoop, right? Scoop is an SQL import export utility. I mean, it's a very lightweight ecosystem component, though it's very important. It's very easy ecosystem component, unlike Hive and Pig. So I'm gonna explain about this and you'll have a case study. And you'll have something like a NoSQL concept called HBase. I'll explain about HBase in detail, architecture, how different it is from a normal RDBMS, what architecture is it using in the background. All the details are something that I'm going to discuss. Basically, I'm going to concentrate on what is a NoSQL configuration, or NoSQL. The term NoSQL is. I'm going to mainly concentrate on that when I'm explaining about HBase, right? And then I'm going to talk about something called Flume and Uzi as well. And we have something called MapReduce 2 architecture, which is called Yarn. So at the end of every ecosystem component, you'll have a case study, right? So that's the reason why I'm telling you this is something that's gonna cover purely on practical stuff, yeah. And for which I require your support on daily basis, yeah. Now I have another 10 more minutes. I'll give it for you guys for your queries. So this is what I'm gonna explain in this 40 hours course, and I have something like a reference, I'll give you reference materials for everything, and I have something like a day-wise session plan, right? So using which, you'll take it as a reference on what all I'm gonna cover in this course. It's a 40 hours course which will have all the details that I'm gonna cover, right? So probably for all the consultancy people, Satish is gonna share these materials to you along with this PPT, right? And at the end of every day session, I'm gonna share the recorded videos. So by any chance, if you miss today's session or probably some day session, you can watch the recordings, and you'll have your data sets available, and you'll have your case studies available, which will be posted to you at the end of every ecosystem component. So this is how the session proceeds for 40 hours, right? Covering the Hadoop entire course, which would allow you to give the certification both for Hortonworks and Cloudera, right? So I'm done with the session. Probably I'll give it for you guys for your questions. Yeah. Big data, Shravan has asked me what is the difference between Big Data Lite 3.0 software compared to Hadoop HDFS tool. Both are same. So that's what his question is. One thing, Shravan, I'm not aware of Big Data Lite, right? And the second thing is, like I said, Hadoop is not a software or a tool, it's a framework within which you have a lot of ecosystem components. Probably, I'm not sure what Big Data Lite is doing, right? But Hadoop has HDFS and MapReduce, which is internal to it. So HDFS is not an external entity for Hadoop. So you cannot compare something with Hadoop HDFS tool. So Hadoop is a framework which has a lot of ecosystem components, which runs with something called MapReduce. Yeah. Or do you want me to unmute you, Shravan? Probably I'll unmute you. You can ask your questions, or if this is unanswered, you can ask me. I've unmuted you, Shravan. You can ask your questions.
Like I would like to ask, are Hadoop jobs in the market or as frequent as like the .NET or Java jobs, or it is like somewhat scarce or very choosy like SAP jobs?
Oh, that's a very good question, because at the end of the course, you are joining just for your job, right? So yep. I say Hadoop has a lot of openings currently, and it will have, because looking at the trend of the data that the organizations are producing, they require data analysts and data scientists for sure, right? Okay. So Hadoop has a lot of jobs. But don't take my word. Don't take my word as a granted. You can go and check in any social networking, any professional networking sites like LinkedIn or probably other professional networking sites. You'll understand what is the demand of Hadoop currently and how many job openings are there. At least in your location is something that you would be preferring for. You just give it a try. You'll get a good picture.
What would be the entry-level position, like the name of the job or name of the position in Hadoop, like what it would be? Like I heard like data scientist is there, data analyst is there.
Exactly.
Like as an entry level, what would be the exact position, name of the position is called?
Yeah, you can have something like Hadoop developer, and that's the developer level. On top of it, you have something like data analyst. On top of your functional and technical, you have something called data scientists. Yeah, okay. And you have data architects, which will be in the same vertical. And to manage all these guys, we have something like admin guys. Hadoop admin guys is another role, right? Okay. So these are the roles available in Hadoop, I should say.
Which of the positions exactly doesn't require much of coding? Like
yeah, I understand.
Yeah,
I understand that. So developer is something who would be mainly concentrating on not coding as such, because MapReduce is the only one you have coding here in Hadoop. See, Hadoop is not a programming language, right? So yep. Internally, Hadoop has something called MapReduce, which is a programming model. So only for that you are gonna do some coding. But on top of Hadoop, there are many ecosystem components like Hive, Pig, HBase, Scoop, Flume, Oozie, Tableau, many things.
Even they are the script language. Even they are the script language.
Not at all. Not at all. If you are an SQL guy, you can use Hive. So you are doing data analytics here. That's the point. You are doing data analytics here. So for which you don't need programming knowledge, at least for 80%. Rest 20% are something which you are gonna write your MapReduce programming models. Rest 80% are ecosystem components. So for which you don't need a programming skill set, I should say. You are doing some data analytics here, right? You are not doing some high-level programming using Hadoop. That's the bottom line.
So only the admins, to answer my question, like, is it the admins who doesn't have the much of coding, the positions?
No, not the admins, I should say. It's out of developer. You will have something like data analysts or data scientists who will not have programming skill set. I mean, you are purely concentrating on data analytics, for which you don't need programming language.
Like, can they be like some entry level positions, or they?
Of course, there will be entry level positions.
Okay. And may I know, like, what is this ORCH Orch?
ORCH, where is it?
Orch library in Big Data. Like, to explain my condition, like, I'm a master student.
Okay.
And we have a subject on big data, but it is only regarding the basics of big data.
Okay.
Nothing like into the depth, but it has covered most of the topics which will be seen in the big data environment. Okay.
Okay.
Like you said, the scope, HBase, Hive, Pig,
okay.
Cloudera, these kind of things. I had known familiar to these terms. Now the thing is, I don't know Java actually to say.
Okay.
I'm from the track web designing track, like HTML, JavaScript, these kind of things.
Correct.
Okay.
Okay.
But this particular things requires Java or Python for MapReducing to write the coding program. It requires this one. Okay.
Yeah, that's what I'm telling Shravan.
Yeah, I know.
Your programming skill sets are only for MapReduce, not for the ecosystem components.
Yeah.
Yeah.
Yeah. So can you tell, is it better for me to go with Java for 1 year and come to Hadoop, or is it fine for me if I directly step into Hadoop soon after my master's?
I would suggest that totally depends on you. If you are able to learn, it's not Java. Java is an ocean, like I said. So you require only core Java. Core Java is not something that is pretty difficult to learn. Anyways, I'm gonna cover this in this course. But looking at your professional level, if you are saying what do I have to do, it purely depends upon your mindset. If you wanted to go for Java, because if you are scared that I may not be able to handle Hadoop, that's for sure. But that's for sure you'll have to go for Java. But on my experience, what I'm telling is, the amount of coding you do on a daily basis on Java is only 20%, rest 80% would be data analytics, right? So probably this should answer, or this should give you some advice on what to do. Parallelly, you will have to develop core Java for sure. I'm not saying the fact that core Java is not required. Core Java is definitely required, but core Java is pretty much straightforward.
Is big data completely related to BI?
No. See, you have business intelligence tools on top of your Hadoop, right?
Okay.
It's not at all BI. You are doing data analytics. On top of your data analytics, if you wanted to apply some business intelligence, you are using some separate BI tools.
Okay.
And I see you have asked about some ORCH internal library, right?
Yep, it's like a repository or a library, I think it is.
Yes, it's a library, like I heard. It's like some data segregation library which will be present in MapReduce, if I am not wrong. Probably, at least it's not a very widely used library, I should say. I never come across for the past 2.5 years for ORCH.
Okay.
Yeah.
Actually, I had worked on the Hadoop. Like, I have hands-on experience on this.
Okay.
Like at the time we used through a virtual machine, we launched and software.
Shravan, just give me a moment. Probably Probably, if you have any queries, probably you can post me, because there are other people as well, right? Probably they they also
Sure.
might have.
I could wait for you.
Yeah.
Go with others.
Sure. Any others? I mean, any other questions you guys have? Shweta, Konda Reddy, Srilekha, Ramu, Rajshekhar, Raghu, Premnath, Durga, Prasad, Bhargava. Yeah. Cool. So can I take it as you don't have any other questions? I can proceed with Shravan's queries. Yeah, Srilekha. I'm just unmuting you. You can post in your query.
I don't have any queries. I'm good.
Oh, cool. I thought you have a question. That's why you had raised your hand.
No.
Okay, fine.
No.
Cool. Yeah, Shravan. You can go ahead. Or 1 second. Rajshekhar has one question, it seems. Yeah, Rajshekhar. I have unmuted you, Rajshekhar. You can post in your query.
Yeah. When is this course going to start?
This course is gonna start from your, I mean, probably you are from US, is it, Rajshekhar?
Yeah.
Your Monday evening, which would be when I talk about IST, it would be 7 to 8 a.m. IST in the Tuesday morning, which would be your Monday evening, which would be 9:30 EST.
Okay.
9:30 p.m. EST on your Monday.
Okay.
Yeah.
And one more thing, like, what is the salary expectations for a developer or an admin job?
Ooh, that I cannot answer. Probably it's like, okay, to tell you the trend, Hadoop is second highly paid technology globally currently. It's the first one is WordPress, second thing is Hadoop. Probably then you can estimate how much of salary that can be expected. That's what I can suggest on a high level, but not exact amount I can say. It depends on your experience, on the location where you are working on. Yeah.
Okay.
Cool. Shravan.
Yep.
Okay, please post in your query, because I had to rush in for another meeting in another couple of minutes. Yeah, please go ahead.
No. Actually, can I talk like?
Yes, of course. Please go ahead. I have another couple of minutes.
Okay. Like during my course, we have launched Big Data Lite through the virtual machine. You know, virtual machine.
Yes,
right?
of course. Yep.
Yeah, through using a virtual machine, we just entered into other OS, and we had opened this one, Oracle Big Data Lite 3.0.
Okay.
We will have an interface, and we have a terminal there. In terminal, we will go for like creating the directory or doing this kind of coding, like you said, the JavaScript code, Java coding is there, right?
Okay.
For map reducing things.
Yeah. Okay.
So, I mean, at that point of time, I just got a confusion, like whether the Hadoop tool is it the big data tool itself is the Hadoop tool.
I mean, big data, like I told, is a term. So when you are talking about Big Data Lite, it can be another tool which can be used for your data analytics. Okay, that's one point. Second thing is, Hadoop is not a tool; it's a framework on top of which you have a lot of tools or ecosystem components to do your data analytics. Right?
Yep.
You got my point, right? So your Big Data Lite can be some tool which can be used for some specific purpose of your analytics. When you are talking about Hadoop, it's not a tool; it's a framework. When it's a framework, it has a lot of ecosystem components. Each ecosystem component can be used for some specific purpose, like your Big Data Lite.
Okay.
Yeah.
And like, is this really very high paid than Java and .NET things?
Of course, sir. You are doing data analytics. You are analyzing data that is being produced in thousands of terabytes on daily basis, which is gonna increase. Yeah.
Can I give an example so that you could say, okay, I'm getting the exact concept of big data. I will just give an example. Okay. Just in half minute.
Sure, please go ahead.
Okay, in Facebook daily we will get so many notifications and this kind of things, game requests, something like that. But while posting that, the likes, hitting the likes or the comments, all this data which is raw will be put in Hadoop so that it will segregate, and it will like you have a particular section to see your feeds. You have particular section to see your friend request.
Correct.
Like that. Is that the exact thing the big data does?
Not exactly. See, when you are hitting some, taking with your example, when you are hitting some like button in Hadoop, you are, in Facebook, you are gonna occupy some 10 kilobytes of space in their Facebook data center. Okay.
Okay.
And when you are, probably if I post a pic, probably if there are some 200 likes, there are 200 into 10 KB, that is amount of data that is being stored in Hadoop data, Facebook data center. Probably if I had to retrieve the comments stored in the image or the likes that are there for my image, right? Probably I wanted to look at it after 2 months down the lane, right? So when I want to scroll my web page, I'm not gonna wait for some, I'm not gonna wait until my web page is loading. It has to be happening in lightning fast. So that means in the background the data has to be retrieved in a lightning fast. So when I had to retrieve the data in a very faster manner, I got to use MapReduce, right? Of course, Hadoop is not using Facebook is not using Hadoop in all the phases, but at least for comment storing and the like storing, for everything it is using Hadoop. To talk specifically for comment storing, it is using HBase. Yeah, you got my point, right, Shravan?
Yeah, I got it. Thank you. Thanks for clarifying my question.
No problem, sir. Yeah. Just give me a moment. I'm dropping a mail. Any other questions you guys have? Thank you for. No problem, Shravan. That's my job. Okay. Seems no one else has raised the hand. That means no one else has any questions. Yes, Shravan, probably your consultancy guys will be mailing you the PPT and all the required materials soon after the session starts. Yeah, you can expect from them. Till then, probably I hope to see you guys in the session. Till then, bye bye and have a nice weekend. Thank you.